everyone, I'm Kelly from Robo. Welcome to my live show. Today I will share with you injection molding process. The injection molding process mainly includes 6-stage mold closing, filling, pressure holding, cooling, mold opening, and mold release. These 6 stages directly determine the molding quality of the product, and these 6 stages are a completed continuous process. This chapter focuses on the 4 stages of filling, holding pressure, cooling, and mold release. About filling stage, filling is the first step in the whole injection cycle, and the time is calculated from the beginning of the injection mold closure to the filling of the mold cavity to about 95%. In the shorter the filling time, the higher the molding efficiency. However, in actual production, the molding time or injection molding is subject to many conditions. About high-speed filling. When filling at high speed, the shear rate is high and the viscosity of plastic decreases due to shear thinning, which reduces the overall flow resistance. Local viscous heating effects can also send solidified layer. Therefore, in the follow control stage, the filling behavior often depends on the volume to be filled. That is, in the follow control stage, due to high-speed filling, the shear thinning effect of the metal is often large and the cooling effect of the thin wall is not obvious, so the rate effect prevails. About fill at low speed, the shear rate is low, the local viscosity is higher, and the flow resistance is higher. When filling at low speed, controlled by heat conduction, because the hot plastic supplement rate is slow, the flow is slow, so that the heat conduction effect is more obvious, and the heat is quickly taken away for the cold mold wall. Coupled with a small amount of viscous heating situation, the thickness of the solidified layer is thicker and the follow resistance at the center part of the wall is further increased. Hello, welcome to my room. Due to the flow of the fountain, the plastic floor chains in front of the flow wave are aligned almost parallel to the follow wave front. Therefore, when the two strands of plastic metal meet, the polymer chains of the contact surface are parallel to each other. In addition, the properties of two strands of metal adhesive are different. In the mold cavity, temperature and pressure are different, resulting in broken structure strengths in the forcing error. Hello, welcome to my live show. When the parts are placed at a high angle under the light and observed with the naked eye, it can be found that there is an obvious joint line, which is the formation mechanism of the weld mark. The weld mark not only affects the appearance of the plastic parts, but also its microstructure is loose, which is easy to cause strength concentration so that the strength of the part is reduced and the fracture occurs. Generally speaking, the strength of the weld mark generated in the high temperature zone is better because the cavity of polymer chains is relatively good at high temperature. It can penetrate and intertwine with each other. In addition, the temperature of the two might strengths in the high. Hello, welcome, good friends. Temperature region is relatively close, and therefore properties of the metal are almost same, which increase the strength of the welding region. On the contrary, in the low temperature area, welding strength is poor. About pressure holding stage, the role of the pressure holding stage is to continuously apply pressure, compacts the metal, and increase. Hello, good friends. The pressure of the strength behavior of the plastic during the pressure holding process. The black pressure is higher because mold cavity has been filled with plastic. In the process of retaining pressure, the screws of the injection molding machine can only slow moving forward slightly, and the follow speed of the plastic is also relatively slow, and the flow is called retaining pressure flow because the holding stage plastic is cooled and solidified faster by the mold wear, and the metal viscosity increases quickly, so the resistance in the mold cavity is very large. In the later stage of pressure holding, the material density continues to increase, and the plastic parts are gradually formed. The pressure holding stage should continue until the gate is cooled and sealed, and the cavity pressure in the pressure holding stage reaches the highest value. The pressure holding stage, the plastic exhibits particularly compositive and characteristic to the high pressure. In the high pressure area, plastic is more dense and the density is higher. In the low pressure area, the plastic is more loose and less dense, so the density dispensated change with the location and the time. During the pressure holding process, the flow rate of plastic is very slow, and follow longer plays a leading role. Pressure is the main factor affecting the pressure retaining process. During the pressure holding process, the plastic has filled more mold cavity, and gradually solidified metal acts as the medium for transforming pressure. The pressure in the mold cavity is transformed into the force of the mold wall. Hello, welcome, good friends. Mold by means of plastic, which tends to open the mold, so the mold is locked by the right clamping force. Under normal condition, the expansion force will slightly push the mold apart, which is helpful for the exhaust of the mold. However, if the expansion force is too large, it is easy to cause the raw edge, the molding product overflow, and even open and mold. Therefore, when selecting An injection molding machine. An injection molding machine with a large enough clamping force should be selected to prevent the situation of mold expansion and the efficiency maintain pressure. On the new injection molding environmental conditions, we need to consider some new injection molding processes such as gas-assisted molding, water-assisted molding, foam injection molding, and so on. About cooling stage in injection molding molds. The design of cooling system is very important. This is because the mold plastic products can only be cooled and solidified to certain rigidity, and plastic products can be prevented from deformation due to external forces after demolding, since the cooling time amounts for about 70% to 80% of the entire molding cycle. A well-designed cooling system can significantly shorten the molding time, improve injection molding productivity. Hi, good friends. Is there anything we can do for you and reduce costs? Improper design of cooling system will elongate the molding time and increase the cost. Uneven cooling will further cause rapid deformation of plastic products. According to experiment, the high good friends head from the metal into the mold is roughly dissipated in two parts, one of which 5% is transformed to the atmosphere by radiation and convection, and the remaining 95% is transmitted from the metal to the mold. Due to the role of cooling water pipe in the mold, the heat is transformed from plastic in the mold cavity to the cooling water pipe through the heat conduction through the mold frame, and then taken away by the cooling liquid through the heat convection. A small amount of heat that is not taken away by the cooling water continues to conduct in the mold and spills into the air after contact with the outside world. Factors that affect the cooling rate of products. About plastic products design, many plastic products will thickness. The greater the thickness of the products, the longer the cooling time. In general, the cooling time is about proportional to the square of the thickness of the plastic products, or proportional to the 1.6 square of the maximum runner diameter, that is, the thickness of plastic products is doubled and the cooling time is increased by 4 times. Mold material and the cooling method. Therefore, mold materials including mold core, cavity material, and mold frame material have great influence on the cooling rate. The higher the thermal conductivity of the mold material, the better the effect of the transforming heat from the plastic per unit time, and the shorter the cooling time. Cooling water pipe configuration mode. The closer the cooling water pipe is to the mold cavity, the larger the pipe diameter and the more the lumber, and the better the cooling effect and the shorter the cooling time. conducting flow rate, the greater the flow of cooling water generator essential to expect, the better the effect of cooling water to carry away heat in the way of them for convection. Properties of coolant, the viscosity and the heat conduction coefficient of the coolant will also affect the heat conduction effect of the mold. The lower is the viscosity of the coolant, the higher the heat transfer coefficient, the lower the pressure, and the better the cooling effect. About plastic selection, plastic is a measure of the speed at which plastic conducts heat from the hot place to a cold place. The higher the thermal conductivity of plastic, the better the heat conducting effect, or the lower the specific heat of plastic. The temperature is easy to change, so the heat is easy to escape. The heat conduction effect is better, and the required cooling time is shorter. Machining parameter setting, the higher the material temperature, the higher the mold temperature, the lower the ejection temperature, and the longer the required cooling time. About design rules for cooling system, the cooling channel design should ensure that the cooling effect uniform and rapid. The cooling system is designed to maintain proper efficient cooling of the mold. The cooling hole should be of standard size to easy machining and assembly. When designing the cooling system, the modern designer must determine the following design parameters according to the wall thickness and the vacuum of capacity. Hello, good friends. The location and the size of the cooling hole, the length of the hole, the type of the hole, the configuration and collection of the hole, and the flow rate and heat transfer properties of the product. About mold release. Mold release is when the product comes out of the mold. Mold release is the last step in the injection molding cycle. Although the product has been cold setting mold, but the mold release still has very important impact on the quality of the product. Improper mold release method may lead to the uneven force of the product during mold release and cause product deformation and other defects when injection. There are two main ways of mold release: injector rolled mold release and strapper plate mold release. When designing the mold, the right mold release method should be selected according to the structure. Mold release for smooth movement and no obvious tracks. But injection pressure is provided by the hydraulic system of the injection molding system. The pressure of the cylinder is transmitted to the plastic metal through the injection molding machine screw, and the plastic metal is driven by the pressure, and the nozzle of the injection molding machine enters the vector flow channel of the mold. It is also the mainstream channel, the shut channel, and enters to the mold cavity through the gate. The process is the injection molding process or the filling process. The existence of pressure is to overcome and the resistance in the metal follow process, or conversely, the resistance in the follow process needs to be set by the pressure of the injection molding machine to issue the smooth filling process. 请问你接下这个电话看谁的？During the injection molding process, the pressure of the nozzle of the injection molding machine has to overcome the follow resistance throughout the metal. Subsequent pressure is gradually reduced along the flow length to the most front wavefront of the metal. The exhaust inside the motor cavity is good. The final pressure at the front of the metal is atmospheric pressure. There are many factors affecting the metal filling pressure, which can be summarized into three characteristics. Material factors such as type of plastic, viscosity, structure factors such as type, number, and location of the cooling system, the shape of the molding cavity, and the thickness of the product molding process. Elements about the injection time. The injection time mentioned here refers to time required for the plastic metal to fill in the cavity, excluding and time such as molding opening and closing. Although the injection time is very short and the effect on the molding cycle is very small, and the adjustment of the injection time has great role in the pressure control of the gate, runner, and the cavity. Reasonable injection time is conducive to the ideal filling of metal and is very important to improve the surface quality of the product and reduce the dimensional tolerance. The injection time is much lower than the cooling time, about 110 to 115 of the cooling time, which can be used as the basis of pretending the molding time of the all plastic parts in the mold flow analysis. Only when the metal is completely driven by the screw rotation to fill the cavity, injection time in the analysis result is equal to the injection time set in the process conditions. If the pressure holding switch of the screw occurs before the cavity is filled, and the analysis result will be greater than the setting of the process conditions. About injection molding temperature. Injection molding temperature is an important factor affecting injection molding pressure. The cylinder of the injection molding machine has 5 to 6 gating sections, and each raw material has its right machining temperature. Injection molding temperature must be controlled within a certain range. The temperature is too slow, the plasticization of molten material is bad, which affects the quality of the molded parts and increases the difficulty of the process. The temperature is too high and the low material is easy to decompose in the actual injection molding process. The injection temperature is often higher than the barrel temperature, and higher value is related to injection rate and the performance of the material up to 60 degrees. This is caused by the high heat generated by the shear of molten material as it passes through the injection port. This difference can be compensated in two ways when making a mold flow analysis. One is to try to measure the temperature of the molten material in the air injection molding, and the other is to include the nozzle in the molding. About keep pressure and the time. At the end of the injection molding process, the screw stops rotating and only pushes forward, and which time the injection molding enters the pressure holding stage. During the pressure holding process and the nozzle of the injection molding machine continuously fills the cavity to fill the vacuum left due to the shrinkage of the part. If the cavity is not healed after filling, the parts will shrink by about 25%, especially the tendon due to the excessive contraction and the contraction marks. The holding pressure is generally about 85% of maximum filling pressure, and of course, it should be determined according to the actual situation. About back pressure refers to pressure that needs to be overcome when the screw reverses and stores the material backward. The use of high back pressure is conducive to the dispersion of the color material and the melting of the plastic. Hello, good friends. But at the same time extends the screw retrenchment time, reduces the length of the plastic fiber, and increases the pressure of the injection molding machine. So the back pressure should be not generally not more than 20% of the injection molding pressure. When the foam is injected, the back pressure should be higher than the pressure formed by the gas. Otherwise, the screw will be pushed out to the barrel. Some injection molding machines can program the back pressure to compensate for the reduction in screw length during melting, which reduces the input head and causes the temperature to drop. However, because the results of this change are difficult to estimate, it's not easy to make corresponding adjustments to the machine. About injection molding machine and molding dimensions. The size relationship between injection molding machine and mold is mainly reflected in the following aspects. Maximum injection. The maximum injection volume of the injection molding machine refers to the amount of plastic injection that can be achieved at a time when the screw or plunger of the injection molding machine is injected into the air with the maximum injection stroke. Different plastics have a corresponding pressure region suitable for molding. When designed, the molding pressure of plastic parts should be controlled with the related injection pressure regions of the injection machine, which is not released to plastic material but also related to the size, shape, wall thickness, and the size, the length of pulling area of the plastic products. In short, a reasonable motor set design can improve production efficiency, extend the motor life, reduce costs, and protect the environment and other benefits. When designing the injection molding machine, various factors such as production demand and motor size should be comprehensively considered to achieve the best design effect. My share is here for now. Next, my colleague will share it with you. 为啥？好像灯没打开对。好了，你把灯。
Hello everyone, this is Fiona and welcome to Novo's Lab Show. And today I want to share with you a bicycle process in intelligent manufacturing process. It is sheet metal. And today we will talk about the three parts of sheet metal. The first is techniques of sheet metal, and the second is advantage and disadvantage of sheet metal. The last is factors for choosing sheet metal process. Now let's start with the first part. The sheet metal process includes a series of techniques and which used to transform flat sheet metal into finished products or components. And here is an overview of some common processes involved. Firstly, it is cutting. Cutting is the first step in shaping sheet metal. It can be done through various methods, such as searing, laser cutting, and plasma cutting. Searing means use a shear to cut straight line, and laser cutting means using a focused laser beam to cut precise shapes. And plasma cutting means using ionized gas to cut through metal. And secondly, it is bending. Bending includes deforming the metal sheet to form angles or complex shapes. This can be achieved using tools such as press, brakes, and which apply force to bend the metal at a specific point. Bending is important for creating structural integrity and achieving the desired form. And the next is forming. The forming process is used to create 3D shapes from flat sheet. Techniques include deep join, stamping, and roll forming. Deep join means pulling a sheet into a die cavity to form a cup-like shape. And stamping means using a die to cut and form metal. Roll forming means passing metal through a series of rollers to shape it. And the next is joining. Joining includes connecting many different pieces of sheet metal together. to let the different shipments be made to form sensibilize and the structures. Joining includes welding and soldering and the adhesive and the bonding. Each one offers different strength and cost consideration. Finally, it is finish treatment. Finish treatment are applied to improve the surface quality and appearance of cement. It also can improve the corrosion resistance of products. This may include polish, painting, powder coating, plating, or anodizing. It is depending on the design, outcome, and application. Throughout the whole process, precision and attention to detail are important to ensure that the final product meets specification and performance requirements. Advanced technologies such as CAD and CAM have enhanced the efficiency and accuracy of sheet fabrication. This allows for complex designs and tight tolerance to be achieved at the same. And now let's start with the second part. The shipment process offers several advantages that make it a preferred choice in various industries. Firstly, shipment can be fabricated into a wide range of shapes and sizes to meet diverse design requirements. It allows for the creation of intricate and complex shapes. It is suitable for a wide range of applications. Secondly, cement is famous for its excellent strength to weight ratio. Which providing structural integrity while reducing overall weight. And there are some advantages in industries such as aerospace and automotive. Because lightweight materials are important for performance. And next, sheet metal fabrication process can be highly efficient and cost effective, especially for mass productions, such as cutting, bending, and forming. Additionally, advancements in automation and CAM have further streamline the process, which reduce labor costs and production time. And then next, sheet metal can be easily customized to meet specific design requirements. Whether it's adjusting thickness, changing shapes, or adding features like perforations or embossing. Sheet metal allows for precise customization to meet the needs of different applications. Next is material selection. Sheet metal is available in many materials, including steel, brass, copper, alloys, and so on. Each one has unique properties and advantages. This versatility in material selection makes manufacturers to choose the most suitable option based on factors such as strength and conductivity and cost. Sheet metal products are known for their durability and capable of withstanding brush and the temperature fluctuation and mechanical stress. Painting and coating can further enhance and corrosion resistance and extend the lifespan of sheet metal cabinets. Many sheet metal materials are recyclable, which can reduce environmental impact. Recycling scrap metal not only conserves natural resources but also helps reduce waste disposal and energy consumptions associated with primary metal production. The sheet metal process offers a combination of versatility, strength, and cost effectiveness, making an ideal choice for a wide range of industrial and commercial applications. And of course, there are some disadvantages of sheet metal. Firstly, limited thickness. Sheet metal is typically available in thickness flat sheets. While this is an advantage for many applications, it may not be suitable for projects that require thickness or heavy components. In such case, alternative materials or fabrication methods may be more appropriate. Secondly, Some types of sheet metal, such as steel, are susceptible to corrosion when imposed to certain environments. Proper surface treatments, coating, or the use of corrosion-resistant material can comfort these disadvantages. Thirdly, joining sheet metal components together can be more complex compared to solid material structures. Techniques like welding, riveting, and fastening may be required, adding additional steps and consideration to the fabrication process. And next, certain types of sheet metal, especially those with high tensile strength or hardness, may have limited formability. Complex shapes or intricate designs may be challenging to achieve without specialized equipment or techniques. And next, depending on the fabrication process and the material, sheet metal surface may require additional finishing steps to achieve the desired appearance. Process like polishing, painting, or powder coating may be necessary, and adding time and cost to the overall production. It's important to note that while sheet metal has its disadvantages, they can often be addressed through proper design consideration, material selections, and fabrication techniques. Overall, the advantages of sheet metal, including its strength, versatility, and cost effectiveness, make it a popular choice in many manufacturing applications. And now we come to the last part. Choosing the sheet metal process depends on various factors, such as the specific requirements of the project, the detailed structure of the final product, and the available resource. Here are some situations where opting for the sheet metal process would be beneficial. Firstly, when the design intricate shapes that are challenging to achieve with other materials or process. Sheet-metal fabrication offers the versatility to meet these requirements. And the applications that require components with high strength to weight ratios benefits from sheet metal as it provides structural integrity without adding unnecessary weight. There is many advantages in industries such as aerospace, automotive, and transportation. Shipmental processes are well suited for mass production, especially those are highly automotive due to their efficiency and cost effectiveness. If large quantities of components need to be produced in a short time, sheet metal fabrication is a better choice. Sheet metal fabrication allows for easy customization to adapt specific design requirements or modifications. Whether it's adjusting thickness, adding features, or incorporating branding elements, sheet metal can be customized to meet the unique needs of projects. The application that require durable and long-lasting components benefit from the inside strength of sheet metal. Whether it's outdoor equipment and industrial machinery or structural components, sheet metal products can withstand harsh environmental conditions and mechanical stress. And then, depending on the application, different types of metal materials offer specific properties such as corrosion resistance, conductivity, and magnetic properties. Choosing the appropriate material ensure that the final product meets performance requirements and environmental consideration. Finally, sheet metal fabrication can be cost-effective, especially for mass production, or when compared to alternative manufacturing for specific designs. Factors such as materials cost, labor expenses, tooling requirements and port consideration. Suction efficiency should be considered when evaluating cost effectiveness. The decision to choose the shipment process should be based on assessments of project requirements, including designs and the production volume and the performance standards. Cooperation with cooperation with experienced shipment manufacturers or engineers can help determine the most suitable approach to achieve the desired outcomes. And in summary, shipment is a versatile and valuable materials in the manufacturing industry. Its strength, flexibility, and cost effectiveness make it a preferred choice for producing a wide range of components used in various applications. With advancements in fabrication techniques and design capabilities, the potential for shipment continues to expand, paving the way for innovation in industries worldwide. And that's all we want to share with you. Our company is mainly engaged in intelligent manufacturing business. We can provide customers with project supporting service, including parts machining and manufacturing. And we have some rich experience in many innovative fields, and such as intelligent care products, medical device, automotive products, robots, and automation equipment. If you are interested in our business, you can contact us at any time. And you also can leave your contact information. We will contact you after program. And we would like to help you with your project. We can machine the parts according to your joints, and we also can design just according to your ideas. Making samples for you. Firstly, after confirmation, start a small batch machining or large batch machining. We have a professional R&D team, production team, quality control team to provide you with service. And see you next week. Bye.